Okay, so let's talk about functions. We'll review a little bit before we get into composite functions. So first, let's talk about what a function is. A function is a relationship that assigns exactly one output value for each input value. So what that means is you can only have one x value or one domain for each y value or each range. The domain are the input values or the independent variables, and the range are the output values or the dependent variables. Remember, your domain are your x, your range are your y, and we can remember that by remembering that x comes before y, just like D comes before R in the alphabet. How can we tell if a relation is a function? Well, in this example, as you can see, there's only one domain value for each range. So that is, yes, a function. Example 2, we only have one domain value for each range value here. And for this one, this is a relation that is not a function because we have two 15s in our domain and they both have different outputs or different y values. So this relation would not be a function. Okay, so let's talk about evaluating functions. We talked about this last week and we talked about the function, this being the f function, which is the name of the function. And this function is 3x minus 5. And they want us to evaluate it for the f of 5, which means we're going to take this 5 and we're going to substitute it wherever we see an x, which would be right here. So what that looks like is we're going to take our 5 and substitute it for x, and it becomes 3 times 5 minus 5, which gives us 10. Two more examples. Example 2, we are going to substitute a 5 into the b function. So when we do that, we get 6 times 5 minus 8, which gives us 22. Example 3 is the g function, and they want us to substitute a 2 in for x. When we do that, we end up with 4 times 2 plus 3, which gives us 11. So we have a few more here. Why don't you pause the video and do these 3 examples really quick and check to make sure that your answers look like mine. Okay, so hopefully you ended up with a 3 and an 11 for example 4. Example 5 looks a little different from the ones we've done. However, you solve it the same way. So hopefully you got a 1/5 and a whole number 1. And example 6, notice instead of plugging in a number value for x, we're actually plugging in a variable. So for the first one, instead of an x, we're going to plug in a w. And the second one, we're going to, in place of x, plug in a w plus 1. Now, do you see anything wrong with this problem right here? Well, really, this problem should look a little different because on this problem, what we really need to do is we really need to not have a w plus 1. We need to make sure that we are, and that's not supposed to happen, we need to make sure that we have parentheses around this w plus 1. Because if we do not, then it's very easy to forget that we're multiplying this 2 times everything that's in this value for x, which would be the w and the 1. So really, this problem should not be 2w plus 1. It should be 2 times w, which is 2w, plus 2 times 1, which is 2. So be careful with those. Whenever you have more than one term that you're plugging into your function, you have to make sure that you use parentheses. Very, very important. Okay, so let's talk about the composition of functions. What does that mean? Well, for the composition of functions, it means we are going to take one function, which here would be the f function, and we're going to add it to another. So this problem is asking us if the function f of x is equal to 4x plus 9 and g of x is equal to 2x minus 15, then we need to find f plus g. So that's asking us to take the f function and add that to the g function. Notice we're not substituting anything at this point. All we're doing is taking the two functions and combining them. So that looks something like this. We have our f function here in red, our g function here in green, and all we're going to do is combine like terms. 4x plus 2x gives us 6x, and 9x minus, not 9x, 9 minus 15 gives us a minus 6. So our answer for this one would be 6x minus 6. And for a similar problem, for this one we have to do the f function, same g function, except now we're going to subtract them. Now let's remember, when you are subtracting more than one term, you always have to be careful and use parentheses for this one. So, same idea, we're going to take the f function and we're going to subtract the g function. However, we cannot leave this like this. We must put it in parentheses because this reminds us that we have to distribute the negative and it changes the signs. So we end up with 4x plus 9 minus 2x plus 15, which 4x minus 2x gives us 2x, and a plus 9 and a plus 15 give us plus 24. So this is a composition of functions where they're not giving us two separate functions. They're asking us to just use the f function, but to plug in a 3 into the f function and add that value to the f function when you substitute a 2. So this one we're going to set up just like the others. We're taking the f function here where we're going to plug in a 3, and we're adding that to the f function where we're going to plug in a 2. So on the left in the red we have the f function with the 3 substitution, and on the right side we have the f function with the 2 substitution. So if we simplify both of those sides, we end up with 7 plus 5, which gives us a value of 12. Notice how different this one looks because there are no variables in your answer. You are simply getting an answer for the f of 3, getting an answer for the f of 2, and you are combining those two to get one answer. Now, how do you solve an application problem with functions? Well, really, they're pretty simple. You are just going to take the function that they give you, which this one is for a bullet that is being shot. So it says a bullet shot straight up is s feet above the ground after t seconds, where s is equal to the f of t, which is equal to negative 16t squared plus 256t. And we need to find the height of the bullet after 3 seconds. They tell us in the problem t is the number of seconds. So that means we have to take this function and plug in a 3 for t. So that gives us negative 16 t squared, which is going to be 3 squared, plus 256 times 3. I'm trying to write with my mouse, so no laughing at my handwriting. Okay, so to simplify this, of course, we're going to make this a 9 times negative 16. And we're going to add 256 times 3, which gives us 768. 16 times 9 is negative 144. Add that to 768. And we end up with a positive 662. Excuse me, 624. So the height of the bullet after 3 seconds would be 624 feet. So whenever you have a word problem like this with a function, all you're going to do is plug in the value that is given to you.